Hey friends, just to help you recap very quickly on what we've been discussing. So we said, for example, just to highlight, remember, for example, if you were interested in the second question there, the second question here, show that the probability that exactly 2 of the peppers taken are green. Remember, these were the circumstances: 12 peppers, 3 red, 4 green, and 5 yellow, right? Just to recap, so 2 are green. So you could have 2 greens and 1 non-green. Remember that? So what does that mean for us? 1 green, we could do it this way. We could say 4 out of 12 times 1 more green. You've got 1 less. You've got 3 out of 11 without replacement, times the non-green. I think the non-greens were 8 non-green. So times 8 out of 10 times 3 factorial for 1, 2, 3 over repeats being green 2 factorial. Remember that? That is one way of doing it. Instead of doing green, green, non-green, non-green, green, 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 non-green, green, and then having to add all of those up, right? Because you had to do each of these individually, then add them up. This was the alternative way of doing it, right? Or we said the other way you could have done it is that you recognize that there are 2 greens there. So you could have said, how many greens are there? There were 4 greens. So it's 4 choose 2 greens times 1 non-green times 8 choose 1 for 1 non-green all over unrestricted, which is 12 choose 3. All right. That was the alternative way of doing this question, right? That's what we've discussed, and really important that you understand that. If you do this method, this one here, there is no factorial. No what? Factorial at the end. Okay, if you're going to use the choose method. All right, it's just important that you have grasped that. And now let's do the next question. If the probability distribution of the random variable x takes the value x with probability kx, I'll repeat, the random variable x, so x is x. That's what they're saying, right? X is x, right? So you've got x and you've got the probability of x is equal to x at the bottom. That's what the probability distribution tables look like, right? Obviously, the probability is at the bottom. So x is x, right? And probability of x is what they're interested in as well. So if x is x, and what are the x takes on these values? So x could be 5, 10, 15, 20, and 25. That's what x is, right? You concur? And then they said 25 there at the end. However, the probability is kx. The probability is kx. I need you to pause and think and solve this yourself if you can before you continue to watch the video. Pause, think, and solve. The probability is kx. What does that mean? It's k times x, basically. K times x. So it's k times 5, which is x, k times 10, k times 15, k times 20, and k times 25. Is that what they're saying? Probability is kx, k times x, isn't it? Right now, you know, of course, that all of these at the bottom should add up to, should add up to what? Should add up to 1, right? So you're going to say 5k plus 10k plus 15k plus 20k plus 25k should all add up to 1. That makes 75k equal to 1. K is equal to 1 over 75. And therefore, it's quite easy for you to fill in the probabilities now, right? You know k is 1 over 75, right? So therefore, what are the probabilities? Quite easy. So this probability becomes, that you need to do it in this question. They haven't asked you to do it. But for example, this one would become 5 over 75. This would be 10 over 75, 15 over 75 for that probability, 20 over 75, and 25 over 75. Okay, I hope that makes sense. That's how you'd attempt that question. All right, so remember, probability is kx. It just means k times x, and x is 5. So k times 5, for example. X is 10, k times 10, etc., etc. All right, not deep. All right, quite literal. All right, next one. Example 4.5. Read the question. The question is, Petra has two fair tetrahedral four-sided dice. The faces on each die are labeled 1, 2, 3, and 4. One die is red, the other is blue. Peter, did I say Petra? Peter throws each die once. The random variable x is the sum of the numbers on which the dice lands. Find the probability that x lands on 4. All right, so there's two ways of doing this. You could do it circumstance-wise, where you've got a red die, right? You've got a red die, and you've got a blue die, isn't it? Right, so the red dice that x is 4. What does x represent? X is the sum of the numbers on the dice. X is the sum of the numbers on the dice, right? Red, how could I get 4? I could have red with 1 and blue with 3. I could have red with 3 and blue with 1, or I could have red with 2 and blue with 2. Is there anything else you can think of that could make the probability? No, I don't think so, right? So, right, straightforward. So, mathematics now. Red with 1 would mean what? Red with 1 means what? Means it's 1 over 6 times 3 is another 1 over 6. Could I do factorial here? No, because the red color and the blue color are fixed. So that's why I had to rethink the circumstance, right? I had to rethink the circumstances as 3, 1. Because there's red and blue. It's not like that circumstance. If they would just die, maybe I could do the factorial, but because they're specified one is red, one is blue, you have to just keep the columns as are, red and blue. And then plus, this one is 1 over 6 times 1 over 6, plus 1 over 6 times 1 over 6, right? That's all there is to make x being 4, where x is the sum of the numbers, so those numbers add up to 4. So 1 over 6 times 1 over 6, 3 times, would you say? Yeah, 3 times. And the answer should be let's try that again. 1 over 6. There's 1 and 3, yeah, 2 and 2, and 3 and 1. 1 over 6 times, sorry, it's not a normal dice. This dice has 4 sides. That is my mistake. So the die is 1 over 4 times 1 over 4, plus 1 over 4 times 1 over 4, right? Plus 1 over 4 times 1 over 4, correct. So that is 1 over 4 times 1 over 4, 3 times, which should make 3 over 16. That is the correct answer. 3 over 16. All right. This is 3 over 16 when you add them all up. 3 over 16 is the correct answer. All right. However, that is one way of thinking about it, but when you only have 2 die, it's sometimes a lot easier to just draw a space diagram. So, if, for example, this could be 1, 2, 3, 4 for the blue die, right? And you could do 1, 2, 3, 4 for the red die, isn't it? And then the sum, for example, this sum, 1 and 1 makes 2, 1 and 2 makes 3, 1 and 3 makes 4, 1 and 4 makes 5. You get the gist of this. This becomes 3, 4, 5, 6. 3 and 1 makes 4, 3 and 2 makes 5, 6, 7, 4 and 1 makes 5, 6, 7, and 8, right? Sometimes it's a lot easier to do it that way. And you could have then recognized that, all right, to make a probability of 4 is 1, 2, 3 out of how many black items, out of how many probabilities, just still it's 3 out of 16. Okay, so that's just one way you could have done it. The next one, draw a probability distribution table of x. Ooh. Draw a probability distribution table of x. Again, now you're going to think to yourself, x takes on what values? X takes, what is X? Let's define X. X is the sum of the numbers. X is the sum of numbers. Isn't that correct? X is sum of numbers. True? True. Now, so here I'll have X, and here I'll have the probability of X is equal to X, right? What numbers can X take on? X can be, the smallest sum is 2. I'll have 2. X could also be 3. You see that? It's a sum. X could be 4. X could be 5. X could be 6, 7, and 8. Isn't that correct? Now, probability of 2, I see 1 here. So that's just 1 out of 16. 3, I see 2, so that's 2 out of 16. 4, I see 3, 3 out of 16. 5, I see 1, 2, 3, 4 fives, 4 out of 16. 6, I see 3, 3 out of 16. 7, I see 2, 2 out of 16. And 8, I see 1, 1 out of 16. Again, to know you're correct, you must add all of these up and see if you get 1. All right. I hope that makes sense. Perfect. Perfect sense. Now, the last question is, given that X is equal to 6, find the probability that the red die landed on 2. Given that X is 6, find the probability that the red die landed on 2. Now, given has a special meaning to us in stats, we know that, right? It's what we call conditional probability. Now, let's try and do this question here. Probability red landed on 2 given X is equal to 6. This is the given sign. Do you see that? Given equal to 6. This probability would then be divided by the probability of X is equal to 6. All right? Does it make sense? So the probability that A given B would be divided by the probability of B. I hope that makes sense. Probability that A given B would be divided by the probability of B. A given B, probability of B. I hope that makes sense. So probability red landed on 2 given, note the sign here, given X landed on 6 is divided by probability X landed on 6. All right. That's conditional probability. So whenever you see given, that should mean something to you. It should mean anything to everyone. It's really important. So probability red landed on 2 given X is equal to 6, sum equal to 6, would be now equal to, now what does the top mean? Let's stop and focus on the top. What does the top really represent, this top bit? It's so important you understand this. This means that you must fulfill both circumstances. You must what? Fulfill both circumstances. It doesn't mean multiply or add like I've heard some kids say, weird kids, all right? It means that you fulfill both circumstances. You fulfill red landing on 2 at the same time fulfilling that the sum is equal to 6. Both must happen. Now let's look at our space diagram here. When does red land on 2 and at the same time the sum is 6? I think it's this one here. Red lands on 2 then, and the sum is 6 here. See both circumstances being fulfilled. Red landing on 2, yep, and the sum being 6. There's no other circumstance. For example, does this one qualify? This one here. Does it qualify? And the answer is no, because it's blue landing on 2, even though the sum is 6, but it's not red landing on 2. So it's very specific to fulfilling both circumstances. It's red landing on 2 and the sum being 6. So I see there's only one there. And the answer to that question is this top one here is, the answer to that top one is actually just 1 out of 16. And the bottom one is the probability that X is 6. Well, that's not too hard, is it? Where do I say the sum being 6? I see the sum being 6 there, the sum being 6 there, and the sum being 6 there. All right, so how many are there? There are 3 out of 16. There are how many? 3 out of 16. So the answer is just, final answer, put this both into your calculator. 1 out of 16 over 3 over 16 gives you 1 out of 3. Right. So I hope that makes sense in terms of conditional probability. All right, let's keep going. It's in well. Almost at the end. Right, next one. Natasha plays a fairground game. Ooh, does she? She throws an unbiased tetrahedral die with faces 1, 2, 3, and 4. 1, 2, 3, and 4, right? If the die lands on the face marked 1, she pays $1. Okay? If it lands on 3, she wins 30 cents. And if it lands on 2 and 4, Natasha wins 50 cents. There's a lot of information to process here. So it's just so important, young people, that you it's just so important that you write this out in a way that makes sense, right? So the tetrahedral dice enabled 1, 2, 3, and 4, all right? If it lands on 1, she pays $1. So landing 1 pays $1, right? If it lands on 3, she wins 50 cents, okay? So lands on 3, wins 30 cents, 0.3. Is that correct? If it lands on 2 or 4, she wins 0.5. But it's just so important that you declutter all of this, right? That you what? You just separate it in a way that makes sense for your brain, right? Find her expected profit, right? You cannot find her expected profit without drawing a probability distribution table again. So they want expected profit. So what does X represent? X represents profit, right? X represents profit, right? Obviously. All right. Okay. So I'm assuming she throws this just once, right? She throws an unbiased die. Depending where it lands, that's what she gets. So she has to pay $1. Okay, if she has to pay $1 if it lands on 1, all right. So X is profit. X is what? Profit. What are Natasha's possible profits? Right, you have to think about that. If it landed on 1, she's paid $1. So her profit is minus $1. You concur? Minus 1. If it lands on 2 or 4, a profit is plus 50 cents. Right? Plus 50 cents. So it's 0.5. And if it lands on 3, her profit is 30 cents. 0.3. Remember, you cannot find her expected profit without a probability distribution table. So in the bottom, of course, is probabilities. Now, the bottom is probabilities. What is the probability of landing on 1? So you get $1, which is the first item we discussed here. What's the probability of landing on 1? So you get $1. The probability of landing on 1 is 1 out of 4. It's an even die, so it's 1 out of 4. The probability of landing on 50 cents, there are 2 of them, so it's 2 out of 4. The probability of landing on 30 cents or on 3 is 1 out of 4. And again, check. Do these add up to 1? Which I think they obviously do. So now expectation. Ooh, sorry, now I've lost it. Where were we with our table here? Where X is profit and probability of X is equal to X at the bottom. And we said we could get $1 minus $1, so minus 1. You could get plus 50 cents or plus 30 cents. And then we said minus $1 was 1/4. There was 50 cents was 2 out of 4. And 30 cents was 1 out of 4. And we check that these add up to what? These add up to 1, obviously. Now, expectation, pay attention, my friends. Expectation is equal to the summation of X times P. What is expectation? The summation of X times P. Basically, it is 1 times 1/4 minus 1 times 1/4. Do it here. Minus 1 times 1/4 plus 50 cents times 2 plus 0.5 times 2/4 plus 0.3 times a quarter, so 0.3 times 1/4. Put all of that into your calculator. So expectation is the summation of x multiplying p, x multiplying p, x multiplying p added together. And the answer to that question should be 7.5 cents. 7.5 cents or 0.075, I think. 7.5 cents, 7.5 divided by 100. And the answer is, $0.075. Okay. I hope that makes sense. Brilliant. Okay. That is that. And then, next question is this one. Before we attempt the question, maybe it's important that I point out some things now to you. So how do I get expectation from a probability distribution table? Expectation is equal to the summation of x times p, right? Otherwise known as mean, right? Mean, mu or mean. Variance now, on the other hand, is equal to the summation of x squared times p minus this mean, this one here, the mean, or minus mu squared, right? Minus mean squared or expectation squared. That's how you get variance. And of course, standard deviation will be equal to the square root of the variance. All right. I hope that is as clear as mud. All right, let's read the question. So what is our takeaway point? Expectation is equal to the summation of x times p. We call that mu. Variance requires the expectation, requires the mu. It's equal to the summation of x squared, the x value squared, times p minus the mean squared. All right? Please learn, my friends. Don't intend to learn later. Learn now. Okay. I hope that makes sense. Okay. Without any further ado, let's attempt the question. One question apart. There we go. Attempt the question. First question. The discrete random variable x has the following probability distribution table. Right? Write down the equation that satisfies a and b. All right? That's not too hard, is it? That should be easy. You should be able to say that these probabilities will add up to 1. So you've got 0.3 plus a plus b plus 0.25 should all equal to 1. Right? So the equation is a plus b eventually simplifies to 0.45. Right? That's easy enough. Given that the expectation is 4, what are they saying? Summation, if expectation is 4, summation of x times p should equal to 4. What does that mean? It means 1 times 0.3 plus 3 times a plus 5 times b plus 7 times 0.25. All of those should add up to 4. That's what expectation is, right? And that should give you a second equation. That is eventually 3a plus 5b is equal to 1.95. Yeah, I think it simplifies to that. So using this equation here, equation number 2 and equation number 1, you can solve simultaneously. Please solve by elimination. I don't know why kids solve by substitution. Such questions, learn to do the elimination. And your a is equal to 0.15 and b is equal to 0.3. Right? Try that yourself. It is not that deep. Right, the next question is this one. This one is where I want us to be. Probability distribution table. The probability distribution of the discrete random variable x is shown below. Find the variance x, the standard deviation of x. Right? How do I find a variance? Right? Remember, before I can get variance, what do I need? I need expectation. So expectation is equal to summation of x times p, right? I need that, so I'm going to say 1 times 0.3 plus 2 times 0.5 plus 3 times 0.2. What does that give me? That expectation should be 1.9 as the expectation, right? This is otherwise known as mu. Otherwise known as mu. Then they want but the question is, once they want the variance, how to get variance? So variance of x, like you should know now, say it out loud, summation of x squared p minus mu squared, right? Mean squared. So it's going to be x squared, so it's 1 squared times 0.3 plus 2 squared this time times 0.5, right? Plus 3 squared times 0.2. You understand that? All of this added together, you subtract the mean squared. What is the mean? The mean was here, so 1.9 squared. Okay, and that should give you 0.49. Perfect sense, right? Of course, perfect sense. And the last question there is find standard deviation. Not rocket science at all. Standard deviation is equal to the square root of the variance, right? So just square root of 0.49, and the answer should be 0.7. All right, I hope that makes perfect sense. All right, and I think this will be our last question. Marvelous. Let's read it. Why do I keep doing this? All right. Okay, there we go. A small farm has 5 ducks and 2 geese. 4 of these birds are to be chosen at random. The random variable x represents the number of geese chosen. 5 ducks, 2 geese. 4 of these birds are chosen at random. So how many birds are we choosing? 4 of these birds. 5 ducks, 2 geese. Good to know. 4 chosen. X represents the number of geese chosen. Ooh. So what is x? Number of geese chosen. Just good always to define your x, right? Good to define your x. X is the number of geese chosen. And the bottom, of course, is probability, right? Of x is equal to x. Probability comes at the bottom, isn't it? Probability at the bottom. So out of 4 birds chosen, how many geese can I have? Let's think that through. You got 2 geese. Ooh, interesting. And 4 birds are chosen. So you could have 0 geese. I think that's probable. You could have 1 goose, and you can have 2. You can't have more than that. Even if you choose 4 birds, you can only have a maximum of 2. 0, 1, or 2. Obviously, right? Now, let's work out the question. Let's work out the circumstance. Let's do circumstances now. So, 4 birds chosen. I'm clear on that. How many birds chosen? 4 of these birds are chosen. If I'm to have 0 geese, that means I have 4 ducks. It's duck, 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 duck. It looks like a duck, walks like a duck. All right, ducks. 4 ducks, obviously, because I have 0 geese. That is, probability-wise, I could do duck, 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 duck. It's first duck is 5 out of 7, right? Times 4 out of 6 times 3 out of 5 times 2 out of 4, right? That's one way of doing it. Or I could say, how many ducks? How many ducks? I'm choosing, out of 5 ducks, I choose 4 divided by unrestricted, which is 7 choose 4. I believe that is the answer. And the answer is 1 out of 7. All right, I hope that makes some sense. Then the next one is 1 goose. 1 goose, so 1, right? 1, remember, number of geese. So 1 is 1 goose. So I have 1 goose and 3 ducks, obviously, out of 4 birds. I could do the choose method. What is that? That is 1 goose, 1 goose, 1 goose. There were how many geese before? There were 2 geese. So I could have 2 choose 1, 2 geese choose 1 times 5 choose 3 ducks out of unrestricted, which is 7 choose 4. 2 choose 1, 5 choose 3, over 7 choose 4, and the answer should be 4 out of 7. Right? Or circumstance-wise, how could I have done this? I mean, I could have said one goose would be, what is one goose? One goose would be 2 out of, probably to present one goose, there's 2 out of 7, times the next duck, which would be 5 out of 6, times 4 out of 5, times 3 out of 4, right? Times 4 factorial over 3 factorial, right? Please be comfortable with both methods. Be very comfortable with both methods. I think that should have led you to 4 out of 7. Okay. And the last one, 2 geese. So it's goose, goose, duck, duck, right? Use any method you like, and then make sure the answer should have been 2 out of 7, and just check that they add up to 4. All right, lovely. Otherwise, all the best and take care.